Good day to our thesis advisor, Engineer Jerry Halibas, to our chairwoman, Ms. Helen Grace Gonzalez, and to our Dean of College of Technology, Dr. Alino Jean San Diego. I am Jenny Dison Bikinia, and I would like to greet you all a pleasant day. Along with my fellow researchers, we will introduce our proposed study entitled Modeling and Simulation of Sun-Saving Machine with Backup Solar Power System. Without further review, let's start. Background and rationale. The sun-saving machine with backup solar power system that can separate unwanted objects in a mixed sun. This paper discusses the modeling and simulation of sun-saving machine with a backup solar power system. The sun-saving or screening machine system are to develop the traditional screening process to improve the time process of saving and its efficiency. Statement of the problem. A simple hand-operated reciprocating sun save with a mesh strainer is the traditional way of saving. Taking in consideration the advancement in technology and industrialization, the need of more efficient sun save must have at the present. The modeling and simulation of sun-saving machine will be answered to improve the efficiency of the process. For the development of the study, we addressed the following questions. First, what design parameters should the researchers consider to develop the sun-saving machine with solar backup system? Second, what development strategy should the researchers utilize to ensure that the sun-saving machine with backup solar system will work? Third, what evaluation procedure should the researchers anticipate and address in order to measure the effectiveness of the sun-saving machine? And last, will the solar backup system manage to run the machine?
For the objective of this study, this paper seeks to model and simulate the sun-serving machine. Here are the specific objectives of this study: to design and create the economically sun-serving machine with the solar backup system, to develop the sun-serving machine with the solar backup system with its necessary equipment using design, development, test, and evaluation strategy, to evaluate the effectiveness of the serving machine using the miniature model. Significance of the study. This study will give consumer an idea of how efficient sun-serving machine on constructing a building. Labor cost and time requirements will be less. This sun-serving machine can separate the sun-selective size particles. Based on the required sun particle size, the saved net can be changeable. The data collected during this study will help future researchers to add more information to the related literature on the research study.
This is our conceptual framework. Next is scope and limitation. This study focuses on modeling and simulating a sun-saving machine with a solar power system. It works in either dry or wet sun. A 12-volt DC motor will be powered by a 12 volts 10 amperes DC power supply adapter for the shaving process. A solar power system is added for the backup power system. To simulate the actual shaving machine, a 1:2 scale miniature model will be created. The limitation of the machine are the raw material. Sand will manually pour into the shaving net. The size of the sand will be shaved one at a time, and the switching of the power supply is by manually using a switch from the main power to backup power. Charging of the battery will only through the solar power system.
For Chapter 2, the review of related literature. In this chapter, the following related literatures are studied for the development of the project model. First, the design and fabrication of automatically driven sun-saving machine. The design of automatic driven sun-saving machine is work based on crank and slider mechanism for the saving process of the sun, which provides reciprocating motion of the saving box. The advantage of this study is the time is reduced in the process of saving. In our research study, the idea and the use of slider crank mechanism will be applied in the concept of our sieving process. Second, design and fabrication of sieving machine. The design of this sieving machine is to separate screws, nuts, and bolts, and thus depending upon their size and the size of the mesh used. The mesh of the machine is changeable according to the size of the object to be sieved. The advantage of this machine is simple to construct and easy to use. The concept of changing mesh was applied in the design of our sieving machine model. Third, automatic sand sieve. In this study, a motor-driven sand sieving machine is designed used for the process of sieving sand materials into finer grains. The advantages of the machine: work faster and easily manageable than manual works have. The idea of the motor-driven system will be used in the sieving process in our project. Fourth, solar power operated sieving machine. The solar power operated sieving machine is designed to separate grains from unwanted particles like stones and small pieces of woods. It uses solar energy as the power source of the machine. The advantages of this study is it cost-effective and environmentally friendly machine. In our project, the concept of using solar energy as a source of power is applied as the solar backup system of the model.
For our Chapter 3, the methodology, we discuss the research design. This research contains a quantitative method with statistical treatment that uses experimental research, model, and simulation that involves a wide range of activities, such as fabrication, testing, and evaluation. Data will be collected using 1:2 scale version of the machine. At the bottom of our research design, you can see the prototype of our model, which is the miniature model of the project. Well, to assemble and to run the machine, we address the following components. Mesh holder, which holds the mesh strongly so that the mesh can sieve the sand perfectly. Mesh frame. The mesh frame is made up of wood and tin angle bar where the mesh holder will be input. DC motor. A 12-volt DC motor is used in the model to create a rotary motion to straight line motion with the help of a crank and connecting rod for the reciprocating motion of the mesh frame. Caster wheel. It is attached at the bottom of the mesh frame. The purpose of the wheel for the smooth movement of the mesh frame while moving at the top of the main frame. Adapter. A 12-volt DC adapter used for the main power of the DC motor to convert the 220 volts input of the outlet into 12 volts output to be compatible of our 12 volts DC motor. Solar panel. A 12 volt with 6 watt solar panel is used for the solar backup power system. Battery. A battery with a 12 volt and 4 amps is used for the backup power when main power is unavailable in the main tank. Solar charge controller. A regulator for the solar battery that prevents it from overcharging our backup system battery. Mainframe. It holds all the different parts together and keeps them in their appropriate position. It is made up of steel, angle bar, and rectangular steel tube. Research instrument. The research instrument of the project contains a quantitative method in gathering data for testing and evaluating the machine. And the apparatus we use is the SketchUp Pro software will be used to design the virtual prototype. Excel 2016 software to acquire the average from the data collected by testing and evaluating using one-way ANOVA or F-test. Research instrument. The research instrument of the project contains a quantitative method in gathering data for testing and evaluating the machine. And the apparatus we use is the SketchUp Pro software will be used to design the virtual prototype. Excel 2016 software to acquire the average from the data collected by testing and evaluating using one-way ANOVA or F-test. Data gathering procedure. This research study involves an experimental evaluation in which this study will measure how fast the dry and wet sand can be saved in the machine with a selected weight of 1 kg, 1.5 kg, and 2 kg, and to measure the capability of the backup system to run the machine using the following selected weights. And for a research setting, the study will be conducted at Barangay Gusap, Purok 2C, Cagayan de Oro City. And that's all. Thank you.